planar graph, I already discussed what is planar graph. Euler's theorem that R plus B equals to E plus 2. Two corollaries: E less than equals to 3B minus 6 if B is greater than equals to 3, and if there is a circuit of length 3, then E will be less than equals to 2 multiplied by B minus 4. This is corollary 2. Then Koratevsky's theorem that if any graph which is homomorphic to K33 or K5 is non-planar, homomorphic, that we can find by some elementary subdivision. Today I will discuss some more examples of planar graph. Example 9, let G be a connected planar graph with 25 vertices and 60 edges. The number of bounded region G is, we already know Euler's theorem. According to this, R plus B equals to E plus 2. B equals to 25, E equals to 60, and R is not given, it is asking number of bounded region. So R will be E plus 2 minus B. What is E? 60 plus 2 minus 25. 60 minus 25 is 35. 35 plus 2, it's 37. So total number of region equals to 37, but as it is asking bounded region, there will be one unbounded region and rest are bounded region. So number of bounded region equals to 36. Next, example 10. If G is a disconnected planar graph with 10 vertices, B equals to 10, 15 edges and 3 component, then R equals to. So here number of vertices equals to 10, number of edges equals to 15, 3 connected component. If there is one connected component, then according to Euler formula, B plus R equals to E plus 2. If there are multiple connected component, then it will be that number of connected component plus 1 in place of 2. So you can write B plus R equals to E plus connected component plus 1. If one connected component, it is 1 plus 1, 2. If there are multiple connected components, so it will be K plus 1. So here what is B? B equals to 10. R will find the number of edges equals to 15. 15 plus 3 plus 1, 4. So R will be 9. Clear? If there is one connected component, formula is B plus R equals to A plus 2. If there are multiple connected component, it will be B plus R equals to E plus number of connected component plus 1. Next example, example 11. If G is a connected planar graph with 35 region and degree of each region equals to 6, then it is asking number of vertices. R equals to 35 and degree of each region equals to 6. Degree of each region equals to 6 means in that region it is bounded by 6 edges. Okay. So degree of each region equals to 6. Let K equals to 6. So R multiplication K equals to 2 multiplication E. 2 into number of edges. R equals to 35. K is 6 equals to 2 into edges. 35. 6 divided 2 is 3. 35 multiplication 3, it's 105. We got number of edges. Next we'll apply the Euler formula for finding B. So B plus R equals to E plus 2. B we don't know. E is 105 plus 2 minus R. R is 35. Answer will be 72. There are 72 vertices. Next example, example 12. In a connected planar graph, B equals to 20, E equals to 30 and it is asking K. We already know that number of region into K equals to 2 into number of edges. First we need to find R, then we can find degree of each region, right? So B is 20, R will find E is 30. So R equals to 30 plus 2 minus 20, it's 12. Now got the 12, now put in this formula. So 12 into K equals to 2 into 30. K will be 2 multiplication 30 by 12. So degree of each region equals to 5. Next, example 13. Maximum number of edges possible in a simple connected planar graph with 8 vertices is. There are two corollary, corollary 1 and corollary 2. Corollary 1 is A should be less than equals to 3b minus 6, and corollary 2 is A should be less than equals to 2b minus 4. So corollary 2 is for if there is a circuit of length 3, if there is a triangle. If it is not mentioned about circuit of length 3, then use corollary 1. So here we'll use corollary 1, that A should be less than equals to 3b minus 6. So here b equals to 8, 3 into 8 minus 6, 24 minus 6, it's 18. So number of edges should be less than equals to 18. So you can say maximum number of edges possible in a simple connected graph with 8 vertices is 18. Next, example 14. Minimum number of vertices necessary in a simple connected planar graph with 14 edges. Here we'll also apply corollary 1. E is given and it is asking maximum number of vertices. So E is less than equals to 3b minus 6. 14 is less than equals to 3 multiplication b minus 6. So this 6 we can take to left side. 20 is less than equals to 3b. So b should be greater than equals to 20 divided 3. It will be 6 point something. So we can consider 7. So minimum number of vertices necessary in a simple connected planar graph with 14 edges is 7. Next, example 15. Number of vertices equals to 10. No triangle. Number of edges in G cannot exceed. No triangle means no circuit of length 3. No circuit of length 3 means we will use corollary 2. E should be less than equals to 2b minus 4. Here number of vertices given is 10. So 2 multiplication 10 minus 4. 20 minus 4, it's 16. So number of edges should not exceed 16. With this I am finishing planar graph. In next lecture I will discuss graph coloring. If this lecture is helpful for you, please like, share and subscribe. Thank you.